For most games, the player's movement is the main way for the player to interact with the game's world. But how does one make the player's movement feel good? I don't know. What I do know is how to make it physically accurate. And that's what I'm gonna show you in this video. But before I do that, this level looks kinda boring, so let's make some changes. I got this water shader from the Unity asset store and I think it looks good, so I'll keep it for now, and I replaced the dry soil texture with grass. I experimented with procedurally placing some plants from the asset store, but I didn't like the end result, so I decided to abandon this idea for now. I tweaked the lighting and the colors a little bit to make it look better and made a couple of simple 3D models using Blender. Those are not placed procedurally right now, I'll work on that later. If you want to know how my procedural generation works, you can check out the previous devlog. I already like how it looks, but to make it look even better we could use post-processing. Before we do that though, let's talk about Unity render pipelines. First, what the hell is a render pipeline? It is basically a thing that takes your scene and displays it on the screen. Unity offers 3 render pipelines by default. Built-in render pipeline, which looks like shit, and 2 scriptable pipelines. High definition render pipeline, or HDRP, which will absolutely melt your PC and will only run on the latest hardware, and universal render pipeline, or URP, which lands somewhere in the middle between the built-in and HDRP. I don't want my game to look like shit, so I can't choose the built-in pipeline, and melting my PC is not an option, so I can't choose HDRP either. I could of course create a custom scriptable pipeline, but that sounds like way too much effort, so the only thing left is URP. And now, it's post-processing time. While playing around with post-processing, I noticed that it works in the editor, but it doesn't work in the game. After looking everywhere for like 20 minutes, I found that Unity decided to hide this tiny little checkbox right there. Thanks Unity. Anyway, with updated visuals, my game looks much better, so it's time to work on the character controller. Having a good character controller is crucial for making the gameplay feel good. Do I know how to make a good character controller? No, I don't. But I do know how to make a physically realistic one, and so do you. You see, there's a high chance that you're already familiar with the laws of motion formulated by Sir Isaac Newton, and they are basically all you need to make a physically accurate character controller. Here's how you can do it. You start with a character. Right now there are no forces applied to it, so it stays still. That's the first law of motion. Mind-blowing, I know. Now let's say we want it to move to the right. How do we do that? Well, we add force using the conveniently named method addForce. How much force should we add though? Well, that's where the second law of motion comes in. The force acting on an object is equal to the mass of that object multiplied by the acceleration. We want our character to walk, yeah I know it's floating, let's deal with it later, walk to the right. Let's assume that it's walking with an average velocity of 5 km per hour, or for my American viewers, 3.1 eagles per freedom. Let's convert it to meters per second. So now let's put it into the equation. Force equals character's mass multiplied by 1.4 divided by delta time, which is basically the physics frame duration. What it means is that when we apply this force to a character that is standing still, it will accelerate in one frame to move with a velocity of 1.4 meters per second. So let's do that. Great, we're moving, but there's one problem with it. You see, we only applied that force for exactly one frame. What happens if we apply it every frame? This happens. So how do we fix it? We can do it by subtracting the current velocity of the character from the desired velocity. In our example, it means that if we try to accelerate to the right while already moving in that same direction, we do not add any new forces. Now let's add gravity using basically the same rules, and let's also add some restrictions on the maximum velocity of our character. And of course there are many ways you can tweak and adjust your character controller to fit in your game. Each game is different and each character controller is different, but I think laws of motion are a good starting point for understanding how it all works. Anyway, that's all I have for today.